Hi all, welcome to the second lecture of the series of online lectures for CS203. In the previous lecture, we saw two concepts, random variables and expectations. If you are not clear about any of those, I strongly suggest you to go back and look at these concepts. In today's lecture, we are going to expand on these concepts, and the first thing we are going to talk about is something called conditional expectation. So you are familiar with the idea of conditional probability. In this case, you knew that some event had already happened and then you wanted to figure out the probability of some other event. So we talked about probability of A given B. Now we want to define a new random variable. So we have a random variable x which goes from the sample space to real numbers, and now we want to define a new random variable which has new sample space and again gives the value in the real case. So knowing what we have done before, this does not seem very difficult. When we talked about x, the probability distribution of x is equal to x was probability of all the events which gave the value. But now we know that event B has happened, right? So if we know that x given B is equal to x, then we know that x equal to x has happened and event B has happened. So this probability should be probability of this event, but then we should normalize by the probability of B. So this will be the conditional probability of the random variable x. Okay, so remember that we need a normalization to make sense of this random variable. Once we have this probability distribution, we can also talk about the expectation, conditional expectation of this random variable. So I want to define expectation of x given some event, and looking at it, we already know that event A has happened. So in that case, my expectation should be probability of W, x of W, where W comes from A. Some thought shows that this is again not normalized. If we know that A has happened, then PW should be changed to PW given A. Okay, so once I substitute that, I get that this quantity is equal to PW XW divided by PA. A better way to write it is 1 by PA summation W element of A PW XW. So this is the expected value of x given A. With the knowledge of expectation of x given A, we can define a new theorem, which is partition theorem for expectation. Okay, so the statement would be given disjoint events B1, B2, Bk, expected value of x can be calculated by looking at each individual expectation. So what is the each individual expectation? You first find the probability of Bi and then calculate the expectation of x given Bi. I will not give the proof of this statement. At this point, you should pause the video and check that you can prove this. Let's see a small application of this theorem. Suppose a miner is stuck in a mine. He has three options. He sees three doors in front of him. This is the miner, and he sees three doors in front of him. Door 1, door 2, door 3. The first door, if he takes, it will take around 7 hours, but unfortunately, it will get him back to the starting point. So this is not the correct way to get out. Door 2, if he takes, then this is the correct door, and in 3 hours, he will move to the exit. If he takes door 3, then again unfortunately he will come back to the starting position and he will lose 5 hours. So the question is, in expectation, how much time will it take the miner to come out? So a small assumption, miner uniformly picks a door. So picking any door, the probability is 1 by 3. So let's see how to calculate this expectation. Suppose x is the random variable which counts number of hours to get out. Obviously there are three important events: di, miner picks, door I. And we want to apply partition theorem. That means expectation of x is summation I is equal to 1 to 3 probability of di expected value of x given the miner pick door di. In this case, probability of di is 1 by 3. So we get 3 expectation of x is equal to summation I equal to 1 to 3 expected value of x given di. So now our problem translates to calculating this quantity. What is expectation of x given d1, given d2, and given d3? The simplest one is d2. The expected value of x given d2. So if he picks the door d2, and he definitely gets out in 3 hours. So this should be 3 hours. What about expected value of x given d1? Pause the video and think about it. I think expected value of x given d1 would be 7 plus he is back to the starting position. So he will still take the same amount of time as before. So I should say E of x. Similarly, by the same principle, E of x given d3 will be 5 plus expectation of x. Putting these things in this equation, you can solve and get that expectation of x is equal to 15 hours. We expect the miner to get out in 15 hours. Okay, so this shows a simple application of conditional expectation using partition theorem. These were some simple stuff about expectation. Next, I'm going to talk about another construct, another property of expectation, but of paramount importance.